cortical explorer, right, is a fun representation of state-of-the-art research that was done as part of the dHCP in order to better understand how the human brain works. And so the real advance here is what came from the dHCP. The dHCP model in itself is providing just a much more sensitive framework from which we can compare different brains in order to better understand different aspects of personality, cognition and disease. Out of the dHCP came the Human Multimodal Parcellation study. And that represents a huge leap forward in our understanding of how the human brain works, because it represents the most cytoarchitecturally accurate mapping of the human brain. In other words, it, for the first time, has generated a semi-automated or data-driven parcellation of the brain that actually really reflects what we already expected from histology. The Cortical Explorer represents a simplified model of the human brain, in which we model the human brain as being considered as a relatively small number of functionally specialised regions connected in a network, and that higher order or more complex cognitive processes in the brain are a result of the communication of these brain regions. And this is extremely powerful because it's already been used to inspire artificial intelligence systems. The whole point of having this simplified model of the brain is you provide a global coordinate system essentially, so that you can compare lots of different brains and see how they're different under a wide variety of different circumstances. So it might be trying to better understand cognitive neuroscience aspects of the brain, so higher order cognitive functions, how you make decisions, and what happens when those go wrong. I know that somebody is at the moment, someone I saw recently at one of these meetings is interested in, for example, teenagers' brains and why do they make such bad decisions. That's her entire research thesis. And it's because these areas of the brain mature more slowly than other parts of the brain. So teenagers are less mentally capable of processing these much more complex decisions than adults. These models of the brain provide a platform from which we can compare across large numbers of different brains in a more focused fashion in order to be able to look at specific cognitive processes and see how they differ. Sometimes you're interested in healthy cognitive processes during development or healthy aging. Sometimes you're interested in disease. So which areas of the brain are first affected by Alzheimer's or Parkinson's, or motor, what is the process of motor neuron disease, or what areas of the brain are affected by schizophrenia. Because then, if you can isolate what regions, then you can perform much more focused studies comparing across these populations using different types of data or different types of analysis to build a model of what's different in these particular circumstances. And in particular cases, that might allow you to provide treatment for subjects or people with different types of disease.